Dankjewel. Or thank you to anyone who's not Dutch. I had to walk on stage and kind of do a Hollywood thing, apparently, which is kind of weird. But yeah. Cool, hi. So this is going to be an hour-long talk, which is a crash course to writing custom Unity shaders, exclamation mark. Now, this talk is kind of going to be an intro level to writing Unity shaders for many, many reasons. I'm going to write some code. I'm going to show off various crazy, silly things. So hopefully everyone's OK with that, and you're in the right place. So firstly, put your hand up if you are a programmer, or you copy-paste code, OK, put your hand up if you're an artist of any variety. OK, put your hand up if you're a game designer. It's basically your job to annoy everyone. OK, put your hand up if you work in Q&A. Technically, everyone should put their hands up, but that's fine. Put your hand up if you work in audio. OK, are you in a band? Used to? OK, that's fine. So every time I ask that question, someone who works in the game industry with audio always puts their hands up and they're in a band. It's like a global thing. Your company doesn't know. Well, they do now, so yeah. So my name's Andy. I'm a Unity evangelist. My family asked me, so that's Tom Cruise stuff, which is a Scientologist. They're very different things. So Tom Cruise hangs out of planes and sits on top of buildings, which sounds fun, but I actually do other stuff. So my name's Andy. I'm on Twitter. It's basically my name, but minus a space. And I'm a content evangelist, which means I'm happy with my job. No, it means I basically create content and use Unity and work at Unity and understand what we're doing, and then come and educate and show people how to do wacky things and interesting things with Unity, and then take what people say, what they like, what they don't like, what games they make, and sort of like funnel it back into the company. So I'm kind of that weirdo middleman thing. I don't go knocking on people's doors asking if they want a leaflet. And I do this in Europe, Middle East, Africa, and Russia, which is just a few small places. So shaders. So I'm guessing that everyone here either doesn't know how to write shaders, or they want to write shaders, or they're very scared of writing shaders. Yes, OK. So I'm going to be talking mostly about shaders. Put your hand up if you've written a shader before. OK, put your hand up if it turned pink. It's just about everyone. OK, so this talk's going to go from kind of the bare bones basics up into doing many different things with shaders. So some people already know bits, some people won't know bits. So it kind of covers that whole entry point. So hopefully before this talk, what the fuck is a shader? After this talk, I know shader kung fu. That's basically my goal of this talk. So most people, when they think of shaders, they see pink. And basically, pink is kind of the error shader that gets swapped in for if something's wrong with your code or something's gone a bit wrong. If you're making a game that's entirely magenta, then it's a great shader to have and a great trick. But most of you are not making pink Minecraft. So ultimately, you don't want things to be pink. And a lot of people Google like shaders beginner, shaders 101, and they see all sorts of crazy algorithms like this, which there's some familiar things like Polygon and Vertex. A lot of people know what these things are, but then you get to stuff like this, and you're like, OK, it's getting hefty. And you get to stuff like this, and you're like, I just want to make things look nice and pretty. Why do I need to learn this? And then you get to stuff like this, and then like I still don't know what Gorad is. Someone here is probably thinking, yep, that sounds all OK. That sounds good. But basically, this talk is going to be a kind of a crash course without actually relating to kind of these big algorithms. It's going to be a very simple bare bones basics. And because it's being recorded, no doubt someone on YouTube will disagree with everything I say. But that happens in every YouTube clip. So I resorted to Wikipedia for useful advice. So it says a program that tells a computer to draw something in a specific way, which is actually pretty damn accurate for Wikipedia. So well done, whoever filled that bit in. And ultimately, that's what I'm going to be talking about, how to make things appear on screen in a certain way using code. So, but why learn shader programming? The built-in shaders in Unity are for generic uses. Therefore, things like this has light, this does this. They're not like grass, fur, cat shader, dog shader, underwater cell-shaded Wind Waker shader. They're not very specific towards specific games. They're more for general purpose and general uses. You can create unique and custom visuals if you know how to write shaders. You can create all sorts of interesting, wacky, amazing things. You can do some really weird stuff, and most of this talk is going to be really weird stuff. Optimization, if you know what's going into the shader, you can then take bits out or replace bits or actually understand kind of what's going slow. I've seen so many games that use very expensive global illumination, really complex shaders on like an iPhone 4, and they're like, why does my game run slow? And it's like, well, does your Match 3 clone really need global illumination? Probably not, so don't use it. But if you actually understood how shaders work, you can then strip that bit out. Shader skills are gold dust. Probably not after this talk. It'll probably become silver dust. But generally, when I visit a studio, I said, how many people know how to write shaders? And it's normally like 1 in 10 actually has someone who actually understands kind of this. So, but after this talk, it's kind of ruined that like statistic. So if you know how to write shaders, it's a beneficial thing. They aren't actually that scary. So I'm going to break it down into saying these are basically your variables in a shader. These are basically your functions in a shader, and kind of similar things that you can understand from other scripts or other programming forms. And they're actually really fun to play with, so I'm going to have a lot of fun. I actually hate PowerPoint a lot, so a lot of this talk is actually going to be in the Unity editor. So Unity shaders, they're written using NVIDIA CG, that's C for graphics, but they're wrapped in Unity's shader lab. So if we take a standard shader like this, or just a normal shader, it basically is built up into kind of like 2 chunks. You have CG, which is the middle block, and then shader lab, which is wrapping around the outside edge. And that's basically because CG needs to send information to Unity, or the Unity editor, and display, and then that has to send information back into CG. So shader lab's kind of like a middle thing, front end, like almost like a front end developer-ish, and CG is kind of like a back end developer, driving a lot of sort of like key values. Now I'm going to be talking about 3 different types, if I actually have time, which probably I won't. Vertex and fragment shaders, surface shaders, and image effects. And a lot of people always get kind of confused what's the difference between a vertex and fragment shader and a surface shader. So without me showing big, fancy pants algorithms, which is probably the more accurate and probably better thing to do, I'm going to use a car example. So the vertex and fragment shader is kind of like building up a car from scratch, and then you can kind of choose what things you put in. Like if you want, so you can see here she's installing a steering wheel, but of course you could build a car without a steering wheel if you choose. Of course, on the right-hand car, buying a brand new shiny thing, you can take out the steering wheel, but then it's difficult to drive. If you're racing go-karts, the one on the left, you could build a go-kart that's pink, has 3 wheels and a squeaky horn from scratch and integrate those things. But if you took this, I don't know cars, what is it? An L? Lexus? Okay. You could take this Lexus. If you try and drive it on a go-kart course or a go-kart track, it's probably not going to fit and not be too good. And that's kind of like a bare bones concept. No one stand up and said, wrong yet, so that's a good sign. So yeah, I'm going to be talking about both of those things. And some people get the Lexus and try and drive it on like an iPhone 4 or a low-end tech. It's kind of a bit wonky. Whereas vertex fragment, you have to build your car or build your shader from scratch, but then you can put different things. I'm going to show both of these sort of methods. So let's talk about this one. So the kind of shader flow is you need to gather your needed information. So in this case, meshes. So Robot Kyle, which is like the most downloaded asset store asset, I think, that has a model which has various data in. So this is such as like the vertices, the normals, the UVs, all sorts of things like that. So you need to gather that information for the shader to use. Step 2, you then need to build it. So in this case, in the vertex function, you're then building this object from this data that you have, such as the vertices, the normals, the positions, and things like that. Kind of think of it like you go to a place and you buy kind of parts for a house, and then you like build the house somewhere in the world. Now, the vertex to fragment is basically the process of taking this and taking a snapshot and putting it on the screen somewhere, because you need to be able to get it to draw. So you're basically sending data to the screen. So you can see here we have our Robot Kyle, and you can see you have like the old Unity blue background as well, telling that it's being drawn on the screen. Then the last step is the fragment function. You then color in its screen's pixels. So basically, you go to each pixel and you say, this is white, this is red, this is yellow. This is where you can have fun with actually coloring it in. So let's say, for example, you're building a house, you buy all the parts, you then build your house, you then take a photo of it, and then you get a pen and you sort of color in kind of that photo and put it on Instagram or whatever. So yeah, that's kind of the rough and ready process without algorithms. And then it's done. Hooray, your object is rendered. And it does it for each object that has a shader as part of this. Image effects as well, they're also shaders, and basically everything that you see on screen. This is basically this probably took me more time than anything, because PowerPoint's a nightmare to actually get boxes to align with stuff. So you have your object data, which is the stuff like position and normals and things. You then pass that to vertex function, you build your object, you then send it to the screen, and then you sort of color in different things in the pixel shader. Or the pixel function, and then you then render your object. Now, at various points, you can also pass in custom data, and most of you have probably done this in some form but not realized it. So custom data is things like you plug in a texture, or you have like a little slider value to make something shiny, or you have a script that modifies a value in the shader and stuff. That's all custom data that hasn't come with a model, but it's instead been passed through via a script, via an animation, or basically anything. And you can pass in custom data to the vertex function, the actual building, which is how you can get shaders that kind of like animate and stuff like this, or wave waves that kind of do this, or fragment to basically get things to kind of look in a different way and in a different style. Everyone okay with that so far? Or everyone here is Dutch and they have no idea what I've just said? Cool, dankjewel. Okay, demo team. Yeah, I hate PowerPoint, so let's do stuff. Okay, so I have a cat. Is it easier this skin or like the other one? Hang on. That's probably easier to see, right? Cool, nice. Okay, so we have here a cat, and this cat has a material on it and has the standard shader, which is Unity's built-in shader that automatically is put on each material when you create one. And I also have here 3 objects. One is a sphere, and one is a cube, of course, because everyone knows this. And one is a quad, and the quad is basically going to represent if I took the cat and kind of rolled it out as a flat thing. So when I manipulate this texture and when I make the texture bounce or animate, basically you can see kind of what it's like if it's rolled out with a rolling pin. Poor cat. So you can see here we have 4 different objects, and they're all using the same material. So as I manipulate things in the shader, you'll be able to see what it actually looks like in a sphere, a cube, on a quad, and on the actual object that's intended to be on, all in real time. Now, everyone here, I hope everyone here, at least knows this window down here. So when you have a material on an object, whether it's a mesh render, or a skin mesh render, or a sprite render, or something like that, you have this material lookup window. And this is being driven generally by ShaderLab to basically say what you can slot in. And we have the standard shader, which has different sliders. You can then like set things to be like red cats and stuff like that. And you have all these different exposed options. Now, Unity has built in like a ton of shaders. I actually can't remember how many in here. And you can use all these things. These are the generic built-in use cases. But we want to create a custom shader from scratch. So to do that, we go down into our project folder, go to our Shader Talk materials, well, the folder I call Shader Talk materials. And underneath shader, I think this is from Unity 5.3 or 5.2. You actually have 4 different options of kind of templates to get going. So you have a standard surface shader, like the car. You're buying a brand new Lexus. Unlit shader is kind of the one that you build up from scratch and integrate the pieces. An image effect shader is suited for an image effect. And I don't know anything about compute shaders, so yeah. So instead, I'm going to create an unlit shader to begin with. And it just creates it as a simple asset. I'll go down here. Let's rename it. Someone give it a name. Dog shader. What? No. OK, I'm not going to crowdsource names. OK, so what's cat in Dutch? Is it literally cat? Really? Wow, OK. So cat unite shader. Yes, OK, cats unite shader. So what I could do is I can open this up, and I'm going to use Sublime. And I'm going to set it to C for C, so you can actually see. No one got that joke, but that's fine. So we have here basically a built-up shader that has a texture you can assign and various other things. Now, what I'm going to do is I'm going to delete all of this. I'm not going to start from scratch. And I'm going to build up this shader with all the sections piece by piece by piece to explain how it works. And I'm going to build up a very simple shader to begin with, one which is just a texture and a color. But then I'm going to plug in all sorts of weird stuff, like turn it into cheese and get it to animate and do all sorts of pulsing and stuff like that. Are people OK with that? Wunderbar. Dankjewel. So you begin with writing at the top of your shader in ShaderLab, shader. That's a pretty good start, right? And then here you can then write what the shader's name is or how it's going to be displayed in Unity. So in this case, I can write custom /talk /unite was it cat shader, if I can type properly. Now, if I save this and I go back into Unity, if I go to my cat and go down into my little material drop-down, you can see here that I have custom. Now, I already have some custom shaders that are pre-written, all in the folders. If I go to talk, unite, cat shader. And I can then set this shader to be part of the cat. You can basically choose it to be in different files. Otherwise, if we didn't do that for all these, there would be like a list of like 500 elements or whatever it is, and everyone get really angry. So yeah, we've successfully made a pink cat. Well done. If this is sort of the style of game that you want, you can leave now, and you've basically achieved it. So, and no one left. That's a good sign. I said that once, and someone once left, and I was like, oh, OK, what a boring game. So the next thing that we need to write in ShaderLab is properties. So properties are basically your public variables that you've probably been plugging data in and out of for any other material, or any other shader material. So in here, we can type in different variables. So if I write, like variables. So in here, I can add different little texture slots that you can then use. So for this one, I'm going to write a main texture. Let's zoom out a bit so I actually have some space. I can then set, that's the reference name. I can then set what its public name is. So if you work with artists, you can actually set up public names saying this uses the R channel, or this uses the alpha, or don't touch this value here, or something like that. So I'm going to set main color, and it uses RGB, or let's just say RGB. Hello. Just to prove that it's not going to autofill and stuff. I can then set what type of variable it is. So in shaders, you can have color, you can have like a 2D, which is texture, you can have a float, you can have a range between two values, and there's a whole range of other things which are on our documentation. And then just like any other variable, I can then pre-type it with some information. So I'm just going to say, if nothing's there, then I can just default to, yes, I'll buy Sublime. I can then default to, everyone here uses Sublime. I can then default to like a white texture, so it doesn't like render pink. And then I can do this also for color. So let's do this with color. Let's do this for, what's color in Dutch? Is it literally kleur? KL? Kleur. Thank you. Thank you well. Kleur. So here I can then set this, oh, actually, oops. So that's a texture for sure. And then this one's going to be a color. So textures you can pass in 2D textures, which are flats, or you can pass in cube maps as well. I forgot that. And then here I can then also set it to be like 11111, which is basically white. So if I go back into Unity, hey presto, we actually have main color hello and kleur. Awesome. We've already done lots of stuff. So if I click this little section here, I can actually set different colors already, and ShaderLab then automatically allows me to have a color picker range. Although it doesn't actually do anything, because I have these values coming into the shader, but they're not actually doing anything with the object. And I also have a little texture slot here. So I could set this texture slot to basically be like anything I want, like bricks. And it doesn't even render, because I haven't told the bricks to render. OK, so let's go back to the shader and type more stuff, because currently this shader is really boring. So the next step that we do is after we have our variables is we create a subshader. Now, a shader in Unity can have multiple subshaders. So you can have something a bit like this. And you can use subshaders for having different values depending on things such as like different target platform. So let's say, for example, you're releasing a game on iPhone, kind of low-end iPhone, kind of like Xbox One, and then kind of like a desktop, like beefy desktop. Obviously, on an iPhone 4, you're not going to want to compute like lighting and GI and all these sorts of things. But on like Xbox One, you do, and then on PC, you will do, but you want to turn it up to 11 and things like that. You can actually create a subshader for different properties in this one thing. Now, I think just about every studio I speak to or I meet in my job always splits it into like a mobile version of the shader and this, so they have their separate pieces here and there rather than having one massive long shader with like a billion things in it. So, but you have that option. So I'm just going to delete subshader and just use one, because I'm not going to build the shader to anything, but I just want to use one. So the next thing that we do is inside this subshader, we create a pass. Now, everyone sort of used passes. It's basically a way of taking the data and then drawing it to the screen. Now, in a shader, you can have multiple passes. So I could have a pass, a pass, a pass, and what it will do is inside the first pass, it will do various elements. Second pass, it will do some more things, and third pass, it will do some more things. But that equates to 1 draw call, 2 draw call, 3 draw call, and it multiplies the number of things being drawn. And then you have all the stuff inside the passes, like shadows and things like that. So I've seen some people go wild and put like 10 passes in one shader, and it's like, you want to get this running on low-end Android? Don't. So my general advice is try and use as few passes as possible, or use all sorts of other tricks. So there's some instances that you would have to use multiple passes for that you can't really get around, and I'll show those a bit later on, but for the time being, I'm going to use one pass. Cool. Right. So that's basically ShaderLab bit done for the time being. There's a lot more you can plug into, and just like with anything in Unity, we have lots of magic methods that do like a billion things automatically that are somewhere in our documentation. But next, we're then going to write the CG bit. So we've done all kind of the front-end bit. We've got our data being shown. We said this is going to be a pass. Now we can actually do the meat and veg and actually kind of generate stuff. So in this one, we're going to open CG and close CG. So this is basically a way of saying, OK, we're now going to start writing C for graphics. So think of it as like in a shader, you're basically writing kind of two sort of languages, and they're sort of talking between each other as well. No one's cried yet, so it means that I'm getting everything right. So at the beginning of this, we need to create two functions in the end. So we need to create the vert function, or the vertex function, and we need to create the fragment function. And the vertex function, if you can remember when I said earlier on, is basically build things. So it's going to build the object. So this is basically going to take the data that you're giving it, and it's going to build it somewhere in the world in a position. Fragment shader, or the fragment function, is basically going to then color it in. So basically, I end up needing these two functions. Now, the first thing I want to do is basically get data from the object to then use. In this case, we're going to write a struct, app data. And in this struct, we then pass in the values that we want to get. And we can choose what we want to retrieve. So we could choose to retrieve something like from the objects such as like the vertices. Choose to pull the normals. We can choose like if there's a vertex color, you can choose to pull like the UVs and stuff like that. And you basically choose. So if you're not going to use the normals at all, you don't have to include the normals in sort of the pull. And for the time being, I'm going to import in the vertex, the objects, vertices, and also the UV, so I can wrap a texture around it. And I can start off by writing this. So I'm going to write it out, and then I'm basically going to explain what this means. So float 4 vertex position, and then float 2 UV texture coordinate 0. So this is a way of storing data within a shader. So I'll explain sort of float 4 and float 2 and things like that. But here is basically our name for what we're importing in. So I could call this vertex or vertex points from mesh, or basically anything. I'm just calling vertex just for simplicity. So this is basically kind of the variable name. Next is basically what I'm going to pull, so the variable type. And then the next thing is kind of what data struct or what data format it's stored in. So a float 4 is basically 4 values. And a float 2 is basically 2 values, and they can be different things. Now, a position is, of course, going to be x, y, z, w, because I want to get the x, y, z, w of each point. And then the UV is basically going to be x and y. And you can get a normal of x and y, and you basically can pull different things. So for a free Unity t-shirt, which everyone was already given, so they've already distributed it, what would a color be? Can anyone guess? Go for it. Float 4? Yeah. And what values would those be? Yes. So a color would be RGBA, and that's how it's stored. Hopefully that sort of makes sense. So the float bits, I'll explain a bit later on when I've got more code down. So we pulled in all our stuff to use. The next thing I want to do is I want to then build up my building function. So this is the one that's actually going to build my object. Now, the first thing that I need to do, really, in CG is actually define what the vertex function is going to be and what the fragment function is going to be later on. So I can set up pragma vertex vert. So the vertex function is going to be called vert. But I call this vertex function, for example. Actually, why not? Let's do that. And then this one's going to be fragment function. So we're basically saying, OK, we're going to have a vertex function that's going to build the object, and a fragment function to then color in the object to some point. And there's another thing you can also do. You can also include different things in different libraries, or CG includes. So in this, we can actually include, let me go to my cheat sheet. Hopefully it doesn't run out of battery, or I'm basically toast. The Unity CG CJINK file, which has lots of helper maths and helper functions that we can actually use to do different things. And there's also one for like lighting. There's one for like all sorts of other things. And you can actually download all like the libraries and all the built-in Unity shaders on our website and play around with them, piece them together, understand the source, and chop and change them. So you can then include those things there. So we defined our vertex function. We defined our fragment function. So what I'm going to do now is I'm then going to create them. So we have our vertex function, and the vertex function is going to output or return to the vertex to fragment function, but I'm going to abbreviate it to V2F, as most sort of like Unity shaders, you'll see it's called V2F for the actual taking it and sending it to the screen. And we're actually going to pass into this, in the parameter, the app data. So we're going to take the app data that we've gathered, or like the house pieces, and actually now build it. And this is basically the weirdest function in the whole thing. And everyone's being so calm, and this is amazing. Thank you. So what we're going to do is we're going to return the vertex to fragment function, vertex to fragment struct. And inside here, we're then actually going to build up our object. But the next thing that we need to do, which is probably one of the most important things, the most important part of this whole process, is this piece here. So the vertex function is going to do various bits and pieces, and it's having fun building objects. It's then got to funnel it into kind of a little funnel, and then eventually go to the fragment function. So you need to say what we want to take from one thing to another thing. And in this case, we want to take the object's position, and we also want to take the object's UVs to then color it in. And the cat's still pink. Don't worry, cat. We will be done very soon. So what we need to do is we then need to create the struct of struct v2f. And then here, we then are going to position. I'll explain what sv underscore position means. It's a bit of a weird thing. And there, so we're basically going to return a position to the screen and then a UV of the object to the screen as well. Now, sv underscore position, from what I could understand, is it's something to do with DX platforms. Like one of the DX platforms came out and said, oh, you have to include it. And I think PS4 does as well. And if I deleted this and didn't include it, the shader would work on basically everything in Unity except for PS4 and I think DX9 or DX10 or DX11, one of those. Or you can write 3 characters, and then it would be fine. So just write 3 characters. And if you're releasing shaders on like the asset store or whatever into the wild, write that. Otherwise, you'll get like a really angry message from some PS4 developer, and oh, you didn't write 3 characters. Why are you so lazy? Yeah. So what we can then do is we can then build it up. So we can then do, this is actually the fun bit. So we can then build our object. So inside here, we can then say the output of the position equals something, and then the output of the UV equals something. So the position, we need to get the positions of the object's vertices, and the UV, we need to get the object's UVs, and then basically pass them to the screen. So here, I'm going to probably write the weirdest bit of code you will see today, and that is we're going to multiply, because basically, because we're using CG, NVIDIA has like a ton of helper functions like lerp and all sorts of things. And NVIDIA's documentation for this is actually really good. So you can see here that the CG standard library has all of these things. I mean, you're probably going to be very familiar with some of these like ceiling or like lerp and length and stuff like that. And basically, you can use all of those things automatically. So what we're going to do is we're going to multiply the OK, this is a really weird thing I'm about to write. Unity underscore matrix underscore MVP. I originally asked someone, a very talented shader programmer, does that mean most valuable player? And they were like, you're an idiot. So yeah. We're going to multiply the positions by MVP. Now, MVP is kind of a unique thing. What it stands for is model, view, projection. So it's basically going to get the model. It's going to get the view from the camera. It's going to get the projection from the camera as well. And then that's going to send it to the screen. It's why if I go to here, and OK, this is going to look a bit weird. It's why if I go to here and my camera is of a perspective, basically this object's being presented to the screen from a perspective depth. However, if I go to here and set it to orthographic, the model and the view and the projection is basically going to equal it to being orthographic with no Z depth. So it's basically going to take into account kind of like how the camera is built and what sort of data the camera is going to be sent and things like that. And we have all sorts of other ones like Unity underscore matrix underscore MV for just the model's view without the projection. And you have all sorts of other things. But basically, that gets it to the screen. And that's probably the weirdest bit of code I'm going to write. Everything else makes sense. Everyone OK so far? No one crying yet? Wow, you're so quiet. This is amazing. Well, everyone's just waiting for the party. Yeah. So the next thing is we need to take the UVs from the fragment and send it to the vertex. This is a really complicated bit of code. We're going to take the input and just do that. There we go. Ta-da. So that's it. We built our object. Now what we're going to do, or after I finished up this sort of bit and then we test this shader, is I'm going to come back and I'm going to start messing around with it and moving all the vertices and doing all sorts of crazy stuff. But what I'm going to do now is I now need to draw it to the screen. So in this is the, draw the pixels of the screen. So color it in. Hooray. So here, I'm then going to return a fixed 4, and I'll explain the difference between float, fix, and fixed in a second. It's the fragment function. And here we're passing in that v2f data. And then at the end, it's kind of the end, so we have to write sv underscore target to basically target it to the screen. It's just something you have to put in there, otherwise everything completely breaks. Now, this function's a bit weird. So whereas with this one, we're passing data in, and then data's then being passed out, this one is kind of the end, so we then need to return 4 values, so RGBA. We have to return a color for that pixel. Now, the best way to describe this is kind of like a glorified for loop. and someone here is going to get angry at me saying that. So the vertex function is kind of going to go through all the vertices of the object, basically cycle through them and update their positions on the screen. So that's where you can modify them, and then they can bounce around. Fragment's going to go through all the pixels and then color it in depending on that. So that's, for example, why like an image effect that's taking up a full screen is going to be costly, because it's going through pixel, 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 pixel across. Whereas if you look at, say, like the cat, it's then going to be like not the full screen and stuff like that. That's kind of the reason why. So when I get to here, I then have to end up with a end color of something or some form. So the next thing I need to do is then take the texture and take the color and then combine them. So I'm going to get the texture and then multiply the color by the texture. Now, I've imported these things in here, but that's been in Shader Lab. So you can see here underscore main texture and underscore color. But we need to get these things into the CG part of our code, because basically they're in Shader Lab, and CG needs to know what they are and needs to know what this data is. This is really easy to do. All we can do is we can then go down to here. Now, it'll recognize kind of this underscore, or basically recognize this reference. So we can go down to somewhere inside our CG and then write float 2. Nope, it's a color, so it's a float 4. Underscore color, because the color's coming as RGBA, as the gentleman. I can't really see anyone. Yep, the person did that. Yeah. And then the next thing we need to do is we need to sample a texture. So we're going to write sampler 2D, because it's a 2D texture, and bring in the, yeah, that's basically all you need to do. And every time you add something to the properties you want to use in CG, you then have to re-import it into the CG part. So next, now we need to do this. So we then need to get the texture and then basically store it as an RGBA value to then return. So in this, I'm going to write a float 4 RGBA, and then this is going to stand for texture color. And this is going to use a function in CG called text2D, where you pass it in a texture, you pass it in the vertices you're going to apply it to, the UV, and you sort of combine them together. So in this, it's going to be underscore main texture, and then in.uv. So we're going to take the texture and then wrap it around the object, and then draw that to the screen. And the next thing that we're going to do is remove end color and actually just tell it to do texture color multiplied by, so we're going to get pixel, multiply it by. Can you guess what I'm going to use? There's literally 2 options. Yeah, color, thank you. So, thank God for that. We basically have written a shader. Now, when you create a brand new shader from scratch in Unity, it automatically will write all this out, including fog and I think 1 or 2 other bits and pieces. But the purpose of me going through is so you can understand this bit is what does this bit does this bit does this. And hopefully that has been useful. Maybe? Everyone's asleep, that's cool. So if I go back into Unity, hey presto, we now have a cat, and I can then implement or basically change various values such as the texture. So I can go to texture and I can say, set up this weird sort of stained glass window. I can then also set up the color and do all sorts of these things. It's basically going to take the texture, wrap it around the UV, and then it's also going to multiply it by the color. So I could do all sorts of wacky stuff. So I could go in here, instead of multiply by the color, add the color. And everything becomes brighter, because rather than taking the 2 numbers and multiplying, it adds them on top of it. Okay, but that looks silly, so I'm going to go back here. Now, the reason why I'm passing in a texture that doesn't fit into the UV of the cat is because it hasn't been set up in that way. Now, I have a cat here, the cat texture here, which has all been set up already in some other 3D modeling package. So I can then find my cat, and then assign it, and then you can see here that I'm basically going to use the cat, and then it's also wrapping to all the other objects. So you can see here I can set the color, and then the cat can then change in tint. All right, so we basically built a shader that's already in Unity that you can already use. Now what we can do now is I'm going to show you how you can then manipulate this shader and do different things by basically plugging in different data. And I'm going to do 2 things to this shader and this cat. The first one is I'm going to turn it into cheese and cut holes out of it with basically very few lines of code. And the other one I'm going to do is basically animate, so you can animate all directly in the shader. So if I go back into the code, I'm going to input in 2 values. So do you want the cheese or the animate one first? I heard cheese animation, so I'm going to do the cheese one. So what we're going to do is we're going to pass in a dissolve texture. So we're going to use a texture to basically cut out the object. And then this is going to be cheese. I'm then going to import this in as a texture, and then set this to be white, so that's just the default. And then I'm also going to do a dissolve amount. which isn't going to be a color and isn't going to be a texture, instead going to be a number. So I have a little slider or a value I can put in. So I'm going to do cheese cut out amount. Yeah, that'll do. And this is going to be a float. And then let's set this to be default of 1. So as I go into here, you'll notice that if I delete that, I then now have a second texture slot. I then also have a number or like a little text box for a float value that I can basically scroll up and down and set different things. Now, if I set something into this, like let's say like bricks, it's basically not going to do anything. It's not going to cut it out and not do anything crazy. So we now need to go through the process of adding in our elements from ShaderLab into the CG. And this is kind of the workflow you're going to do most of the time, because most people here will just go shader, unlit shader. OK, let's get going from there and actually remove things and put things in and out. So we've got our 2 variables we want to set up. I'm going to go down. I'm going to go into CG. OK, let's import these values in. So because we have the dissolve amount, that's just a float. That's one single value. It's not RGB or anything. It's just one value. Now, the next thing I want to do is I want to pull in the texture. So sampler2D underscore dissolve texture. Now, for each type of variable that you import in our shader documentation, it's got all the options are basically going to explain all the different bits and pieces about that. So I'm offloading a lot of stuff to them. So the next thing I'm going to do is then choose what to use this. So could someone shout out, am I going to dissolve the texture or cut out the texture in the fragment or the vertex? Yes, everyone said fragment. Someone said vertex, and they were either like guessing or just said, I'm going to go against the grain and hope it like everyone else was wrong. Or Andy explained it wrong. So I'm not going to do it in the building part. I'm going to play with the building part later. I'm going to do it in the fragment. So because I have a texture now, we want to use the pixel colors from the texture, I'm going to create another texture color. So let's call this dissolve color. It's also a texture 2D, because I'm importing a texture. It's dissolve texture there, and I'm passing in the UV, because I basically want to wrap it around the cat. Now, because we're using CG and we have all those options, CG has lots of different helper functions that allow you to do things very, very quickly. So for example, we can use clip, which basically, if I look in the CG documentation, clip would then, it's quite a fun function, it says, kill the current pixel. That sounds horrible. Kills the current pixel output if any component of the given vector, blah, 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 is negative. So this allows us to take the texture, set it to whatever the slider is, and then basically kill that pixel. So if I show you what that actually does, clip, let's get the dissolve color, and let's get RGB, so all sort of like the 3 values of the texture, and let's subtract this by dissolve amount. So with sort of like basically 1, 2, 3, maybe 4 lines of code, you can then already do something like this. So I have my cat. Let's pick a more appropriate texture like this one. And then I can then set my value. So if I set my value to 0, and as I increase my value to like 0.1, ooh, wow, it doesn't work. Why? That's fine, OK. OK, that should be fine. Maybe I should do this. So what I can do here is, rather than use a float for like a 1 value, I can instead set up a range, because you see that the texture slide, the float slide is basically too erratic. So you don't want your artist to be plugging in like negative 20 million, and they say, oh, it's broken, I don't know why. You can then instead do something like 0 to 1, and then it would then remain within that range. Hopefully this will work. No, it doesn't. Brilliant. But the range should be. I did what with the what? OK. Wow, that's weird. OK. It was Unity. I'll file a bug report later. It's fine. OK, anyway, let's try this. That's weird. My cheat sheet has worked, or someone has sabotaged. No. Pardon? Here? Yeah, OK, never mind. I will, OK, I'll move on and do something else. Sorry about that. Ooh, maybe. Oh, shit, yeah. OK, never mind. I'll sort it out later. OK, let's do something that actually works. So what I'm going to do instead is I'm going to take the vertex and then basically manipulate it. Well, I say that I hope this works. So I'm going to extrude all the normals and pull them out and animate the cat in a different way. So I'm going to extrude by an amount. I'm then going to set extrude amount. Basically, I'm going to set up a value. And then in here, I'm going to set up a float, which is definitely lowercase. Or, well, I'm not even going to trust that anymore. And set this up as another value that I can manipulate. Now, if I want to take my cat and basically take all the points in the cat and offset the normals, or offset the positions, I need to pull in that data. So in here, I'm then going to set float3, normal, and do that. So basically, I'm bringing the position, I'm bringing the texture coordinates, and I'm also bringing in the normals of the cat in all the ways that the points are facing. Now, if I go down into here, now that I've got the normals, I can then go into the builder function that then builds up my cat, and I can then set this up and play around with it. Now, one thing you'll notice here is that I'm passing in the vertex, so I can manipulate the vertex before I actually pass it into the screen. So in here, I can say in.vertex.xyz plus, so I'm going to offset the value by in.normal.xyz multiplied by, oh, I haven't imported that in, so float underscore extrude amount. Extrude amount. OK. Wow, OK. So we actually have a result. So if I set the extrude amount to 0, then my cat looks like this. Now, as I increase and decrease the value, basically it's going to take the cat and all the vertices and then offset it in a way. So that way, I can set the value to something like 0.2. Oh, actually, whoa. And then I'm basically taking my object and then sort of puffing it out. You can see here that the cube box actually like takes the points and then offsets them. So you can see the box sort of opens. You can actually enfold the box, which is super weird and super strange. And this is where the float slider comes in, the range slider comes in use. And I hope this doesn't break. It's a shame. I really wanted the cheese thing to work. Let's set this between like negative 0.1 and 0.1. And set this to be like 0.3 or something. So here, we then have the slider. So you can see that the slider then has the limitation of the edge. And you can't even like plug in a value here. It will basically just return the maximum or the minimum, depending on the way. That way I could take my cat and actually kind of like do some actually really horrible stuff. But then we can animate this. So basically, built into the Unity sort of like to CG, you have different things such as the time value. So the time value allows you to animate something over time. Now, we can do this by manipulating different things. So if I go to here and I multiply this by underscore time.y, so time is actually a float 4, and I didn't learn this for a long time. So basically, time is x, y, z, w. So x is basically like 20th speed. Y is like actual speed. Z is like, I think, double speed or something like that. So the y value is kind of the true speed. So now if I jump into here, my cat is basically just going to keep increasing forever and ever in size. That's not good. And I knew that would work. Yeah, I knew that bit would work. So what we can do is we can instead wrap this in a sine wave. So what this is going to do is it's then going to pulse in and out. And this is going to look horrible. Where's my cat? So I've got my cat. So let's set the value to like 0.1. Actually, that's really mean. Yeah, so now I have a sine wave and animating my cat. Someone will find a use of this in a game. Someone somewhere. But you can see that also the texture here is then coming in and out because the normals are then facing in that direction. The sphere is just kind of pulsing in and out like that. It's kind of OK. And you see the box here is also kind of folding in on itself and then folding out on itself as well. So you can actually animate all within the shader and do different unique things like that. Now, that's kind of some things that you can do. You can also do lots of other wacky, wild things. So if I go to my cat, I can then choose some other shaders that will hopefully actually work. So if I go to my demo, you can do things such as a dissolve, which should work. So I have my cat, and I have 2 different skins for it, orange and pink. And you can see I've got 2 different texture slots. I then can use a dissolve guide, which is basically the same bit of code I was going to use to kill all the pixels, but I'm going to lerp between one status of a cat and another status of a cat by this dissolve amount. So as I change this dissolve amount, you can see here, and let's turn down the tiling, that my cat then dissolves between one thing and another thing like that by that second texture, or that third texture. So I could pass in all sorts of super weird stuff like bricks. So my cat will now dissolve by a brick texture, and it's then going to take the RGB values and then multiply them or offset them and stuff like that. Cool, which is actually kind of funky. Now, other things that you can do is stuff like this. So you could also set up an outline. So using 2 passes, you could have the first pass, which is the outline around the outside, and then the second pass, which is then actually going to draw your detail. Something kind of like Left 4 Dead, but I think Left 4 Dead uses an image effect as opposed to an object shader. So you can see here that all it's doing is in the first pass, it takes the vertices, offsets them, and colors them one color. Then the second pass, it actually does the coloring in properly of how you want it to be. And you can do all sorts of stuff, like you can set the outline width like really long and then like blue. So now my cat kind of has a blue aura around it. I could take that blue pass and actually set a texture to that, so my cat has like a shield wrapped around it doing stuff like that. And you can see it's also happening on kind of like the sphere, and the box is doing all sorts of weird stuff as well. Another crazy thing you can do is do this. So currently my cat is completely invisible, and I can pass in a noise map or any texture and then access the data from that. So if I then give it like this cliff, we can then take the noise, and then you can see that it then uses the noise and then manipulates it. And that's part of a function or a thing called grab pass. So who has played The Sims? OK, leave your hand up if you made The Sims nude. Everyone put their hands down. What's going wrong? So in The Sims, you kind of have that pixelated kind of like, you can tell I have. So you have that pixelated kind of box over the sim, so you can't see the nudity, but you can see kind of the color of the pixels behind it. Now with GrabPass, you can do that. GrabPass then gets the data that it's taking up on the screen, and then you can then manipulate that in a type of way. So what it's doing here is I'm using GrabPass and call it grab texture, but of course I could call grab texture something else. I can then go down, I can then take grab texture, and then I can distort it using a texture. So I could take a texture, take grab texture, and then distort it in a type of way. Now, if I go into here, I can also do various things such as this. So you can also get data that's not necessarily obvious, but is usable as well. So you could get the position of the object in the world. So if I set this up, I then have my object, and it has a green color and a red color and a blend amount. Now, as I move my object in the world, you'll notice that it'll actually change color based on its Y position as well. So if you had a game with, say, objects underwater, when objects are closer to the surface, they kind of have more color. You could set when the negative of a Y value, the deeper they go, kind of the darker they get. Or you could have mountains. So the tops of mountains are white automatically. The bottoms of the mountains are like brown and things like that. So you can actually take data such as world space and then translate them into the shader and do things like that. If I look at the shader code for this one, and set it for C so you can see what it's doing, I have no properties being passed in here, which is the position. Instead, I can go down into my vertex, and I can output the position, which we've already done before, and of course, I can also output a second value, which is world position. And Unity has built-in things such as underscore object to world to get where the vertices are in the world somewhere. And then basically in the color, I can then lerp between one color, a second color, by the world position of Y. So you can actually take that data and take things that are baked in. You don't have to have a script that then passes a value or pushes a value in. There's some things in our documentation it says that you can also tweak things. So I have not much time left. So let's go back to my slides and show you some cool stuff, or some other stuff. I'm actually gutted that the cheese thing didn't work. I'm really annoyed. So surface shaders. So that's all good and all, well, but what about when it comes to lighting? So surface shaders do a lot auto-magically, which is kind of like the Unity way. Like you click VR mode, and it enables about 1 billion things. And surface shaders do a lot. So they light up objects using different object lighting, ambient lighting, reflections. Unity, I think, has like 6 types of light mapping, light probes, and it'd probably do a whole lot more. And when you do the final drawing to the screen, the vertex and fragment shader ends up with a pixel color, whereas the surface shader ends up with you output an albedo map, you output a metallicness, you output smoothness. So if you're used to the standard shader, those are the values that you then output. Now, the left one is then the surface default. So when you create a default surface shader, it's like 41 lines of code or something. And it does lots automatically without you having to set up these things. And surface shaders are there they're kind of like a macro to allow you to do a lot of things very, very quickly. So that brings a lot of overhead. But if you look on the left, you have the surface shader that does all the lighting and everything of Unity. On the right, you have a vertex and fragment shader that just does textures and reflections. On the right, you have something that just does one light and shadows. On the right, you have just a shader that just does light mapping. And then you sort of combine those together and piece these all up, and it still doesn't do as much as Surface Shader. So Surface Shader is kind of like a quick way to get a lot of things automatically working, especially when it comes to lighting. So they do a lot automatically, but this makes them a bit overkill. So it's kind of a macro shader. So the Surface Shader basically kind of boils down into a vertex and fragment shader, and it automates code, which is overhead. It's basically a big no-no for like mobile and super low-end stuff. Like you're making a match 3 coding. Do you need PBR outputs? You're making a 2D sprite pixel platformer. Do you really need like an occlusion map on that object? So the Surface Shader is amazing for getting lots of things and working with Unity lighting very quickly, but it's very expensive if you don't need all those fancy-pants stuff. But it also makes it easier to custom lighting is easier to create. So for example, you have the standard lighting fall-off. So we have the light up here, and this is just a sphere using the standard shader. And you see that the light is then making this side of the sphere light, and then this side of the sphere dark. And then you basically have this nice fall-off. Now, a lot of people always say, oh, how do you make cell shader games like Zelda or Wind Waker, or like, that's not a game, and neither is that one, but they'd be pretty cool as games. How do you do things like that? And basically, you can see here on Link's Tunic that rather than having a smooth fall-off that's wrapping around, it actually has kind of a cutoff here. And you can see as well that on the Comedian that you have a light source about here, and you have kind of a highlight of yellow, and then sort of like a beige-ish color, and then sort of an orange, and then a red. So you kind of have a different colored fall-off. And then here at the bottom from Sin City, you basically have white and black. So they want to be able to do different things and manipulate things like that. And luckily, it's actually really easy to do. So they use a sort of a theme called color ramp texture. So you basically use a texture, and you set up this texture. So at this point of the fall-off, use this color. At this point, use this color. At this point, use this color, and so on. And you can do this. I think that's the exact one from Team Fortress 2. They've just put it on the website, which is pretty cool. You can also do things like blur, sort of like the chunks or the pieces. You can also set like very specific. You can even use like colors in kind of the lighting fall-off. So ultimately, this is my Microsoft Paint, took me about 4 hours to create type thing. We basically can take the texture and then wrap it to the fall-off and then do something a bit like that. So that's quite easy to do. So what I'm going to do is, I already have the code pre-written, so nothing will go wrong, right? Yeah. And I have 2 minutes left. So if I go to this custom lighting fall-off, or let's go to the standard shader, and remove the normal map from the cat. You can see here that my cat automatically has kind of like some shininess and this nice fall-off. If I go to the sphere and I delete my texture and set my color to be something sane like white, you can see that if I look at my sphere from here, you have the light in the top left corner and then darkness in the bottom right. When you create from the asset window, create shader, Surface Shader, it will automatically have all these things set up. Ambient lighting, you change the skybox, it affects it, and things like that. Now, what we want to do is we want to have a look at what that shader code looks like, which is basically, if I have a look here. Now, it has a lot of common properties or things that you'd be used to when it comes to like shaders. So you name the shader at the top that we're already used to, that we've learned that. You have your properties. It's exactly the same before because it's ShaderLab. You also have here magic methods. So here we can say this is an opaque object, but we can go and we can change this to different things. We could set the render type to be transparent, for example. You can also set the LOD level. And here we then open up CG program and then end CG program. So this is stuff that you're already familiar with, like, what, half an hour ago? So yeah. sample the texture. Now, surface shaders are a bit weird in that they basically end up having a surface function that then basically inputs everything and then outputs everything as well. And rather than returning a color or returning a float 4 value, we have here a texture slot, another texture slot, or another value slot, and you basically output into these chunks. Now, if I put this one here, and if I go back into Unity, I've already pre-written what you would do to basically plug in like a ramp or like a color fall off. So if I go to my texture and I go to custom, chalk, lighting ramp, you can see here, and let's turn off shadows because it kind of makes it look a bit weird. And let's make the lighting white. You can see here that with my cat now, you can see that I have my cat. Let's move it to here. I can then choose a different texture, and it's then going to use that lighting fall off from the position of the light and then basically wrap all the way around. I could even like pass in the cat's actual texture itself, and then we have something that looks basically like that. And that looks absolutely horrible, but it's all possible. So if I select my cat and then have a look at its texture or its script, so let's have a look. So we've got our properties at the top on the right, properties on the left, yeah, that's fine. But you notice that this one here for the custom lighting ramp has underscore ramp, and it has that texture slot. As we scroll down, we import that texture slot. As we go down here, you'll notice that I've actually written, and this is when you go to Assets, Import Package, and I think it's under Effects or Cell Shading or something like that. Basically, you can then manipulate in different ways. So here, I'm basically taking the texture ramp using Text2D, and then manipulating that on the lighting fall-off. Now, I have oh, wow, I've gone over by 1 minute. I'm really sorry, Lena. Shoes. Sorry. So I have to basically wrap up super, super quickly. Sorry, I've had to cut this short. So what now? So we have the shader documentation, which you can go in, and basically everything I said is in there. You can actually download all of the built-in Unity shaders and mess around with them. So if you go to the Unity download archive, you can see here that we have a little drop-down. And then we have in built-in shaders. You can actually download that as a big package and dig through them, play around with them, chop and change them, do different things. You can also go to NVIDIA CG documentation, which is actually pretty good. And the Unity community, as I like to call it, the Wild West, because you go there and they've written all sorts of crazy shaders to do fire and flames and water and things like that. And the Unity forums for shaders is pretty good. Now, I've got here a GIF that won't work. OK, whatever. And you can also do this. So I'm a big fan of Team Fortress 2. So just for fun, I typed in Team Fortress 2 rendering techniques. And Valve have actually written like a big render document about how they do all the lighting and all the cell shading and things like that. So you can see here that we have the albedo, the warp diffuse. And basically, they plug in all these values and multiply them and set them up. So you can actually search for things like GDC talks, like Firewatch. How do they do kind of the lighting and that? SIGGRAPH papers, which are quite more technical, but a lot more interesting and things like that. And that's basically the end of my talk. I kind of ran out of time, so I apologize. I'm sorry that no cheese was made, but thank you.